All right. Problem number 8. A marketing assistant for a technology firm plans to randomly select 1,000 customers to estimate the proportion who are satisfied with the firm's performance. Based on the results of the survey, the assistant will construct a 95% confidence interval for the proportion of all customers who are satisfied. The marketing manager, however, says that the firm can afford to survey only 250 customers. How will this impact the confidence interval? As n goes up, what happens to our confidence interval? It gets smaller. As we talk to more and more people, it reduces our variability. So if I couldn't talk to as many people, what would that do? It's going to increase my variability. It's going to make a wider confidence interval. So the confidence interval will become wider. Because the margin of error will, if my confidence interval gets wider, the margin of error will blank by a factor of blank. It's going to increase by a factor of. To figure this part out, I'm just going to plug in some numbers for my margin of error. Like I'm going to find the margin of error with both of these n values. You're on the right track, but it's not going to be a factor of 4. So we're going to work this out, and then we'll talk about how you could do a shortcut on this. Okay? All right, so 1.96 times the square root of, then it would have to be p hat times 1 minus p hat, right? But they didn't actually do it yet, so we don't know what p hat is. What should I use in the place of p hat if I don't know it? 0.5. And so then 1 minus p hat would be 0.5. Okay, so the research assistant wanted to do this with a sample of 1,000, right? All right, grab a calculator and do this real quick. 1.96 times 0.25, or square root of 0.25 over 1,000. You said 0.031, okay? So now let's do it with this smaller sample size. 1.96, everything else is the same. Sample size now of only 250 though. So 1.96 times the square root of 0.25 over 250. 0.062 if we round, right? Going from here to here, you guys agree that that increased, right? By a factor of what? What would you multiply this by to get that? By a factor of 2. Okay, so let's talk about shortcuts here so that you don't have to calculate it each and every time. The sample size got smaller by a factor of 4, right? It was divided by 4, but it's underneath the radical. So if I have something and it's 4 times bigger, 4 times smaller, I've got this 4 on the bottom. What happens when I do the square root of that? I get 2. That's where that 2 came from. Does that make sense? Okay, so whatever they multiplied or divided by to change the sample size, you want to do the square root of that. So from 1,000 to 250, this is a factor of 4. margin of error would be the square root of this. Does that make sense? Okay. So then my margin of error would be different by a factor of 2. What else do you guys want to see or talk about from the review?
Can you do 15?
15, absolutely. The U.S. Forest Service is considering additional restrictions on the number of vehicles allowed to enter Yellowstone National Park. To assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. Random sample of 150 visitors. My pen is giving me all kinds of grief today. 79 of these say yes. So 79 out of 150 is going to give me my p hat. What is 79 divided by 150? What is it? 0.53. Construct and interpret a 99% confidence interval for the proportion of all visitors to Yellowstone who favor the restrictions. When it says to construct and interpret a confidence interval, you got to do the 4 steps. So we have state, plan, do, and conclude. What do we need to state? We got 2 things we need to state. What do I need to state? The parameter. Yes. So P equals, and then confidence level. What is the confidence level? 99%. So we got that one. That's easy. What is P? Yes. The true proportion of visitors to Yellowstone That's fine. I don't have to see state, plan, do, conclude. That's just to kind of help you organize all of the pieces. Who favor the proposal. You want to make sure to get enough context in there. You could say the true proportion of visitors to Yellowstone who favor the proposal to restrict the number of vehicles allowed to enter Yellowstone National Park. This would be sufficient on context. Okay, so there's my state. Then we have to plan. What do I need to do in the plan step? Check your conditions, and then there's one other thing. The name of the procedure that we're going to use. What procedure are we going to use here? Yes, 1 sample or 1 proportion, Z interval for P. And we're going to check our conditions here. How many conditions do we have? 3. What are those 3 conditions? Normality. Oops, I spelled that wrong. Randomness. And what was the third one? Independence. Normality, randomness, independence. What do I need to do for normality? large counts. To do my large counts, we do n times p hat. That has to be greater than or equal to 10. And n times 1 minus p hat has to be greater than or equal to 10. What was our p again? 0.53. And n? 150. So 150 times 0.53 is what? 79. That's greater than or equal to 10. So we're good there. And then n times 1 minus p. What is 1 minus p? 0.47. And that comes out to 70 what? 70.5. Greater than or equal to 10, so we're good. We got our normality. Large counts is good. Do we get randomness? Yes, random sample of 150. And what do we do for independence? 10% condition. Scoot this guy over just a little bit. And how do I do 10% condition? I'm sorry, I didn't hear this part. 150 has to be less than or equal to 10% of which visitors? All visitors to Yellowstone Park. So there has to be at least how many visitors to Yellowstone? At least 1,500 visitors to Yellowstone. Is that a safe assumption? Absolutely a safe assumption. You have to make reservations now to go to national parks. I know, that like kills me. I did this trip a long time ago now, but we just like drove around the West and went to a bunch of random national parks and camped, and we went in, and you can't do that anymore. You have to plan it all. There's no spur of the moment like, let's go on a road trip. At least not without some advanced reservations. All right, so there's state, there's plan. Now we need to do. How do we do a confidence interval? What is the big idea behind a confidence interval? Point estimate plus or minus margin of error. Nope. Nope, I'm writing it down because I want to know that we all know what to do here, but if you don't write down point estimate plus or minus margin of error, that's fine, but you have to reference it with the formulas.
Do you have to like write the formula without the numbers and put it?
I don't have to see that, but I would prefer to see that. What is our point estimate? Like what represents our point estimate? P hat. Plus or minus, here's why I would really like to see formulas though. Margin of error has two parts to it. What are the two parts of the margin of error? Z star and the standard error. And how do we calculate standard error? Yes. Standard error is p hat times 1 minus p hat over n, and then square root that whole thing. Let me see if I can zoom in a little bit more here. All right, we're going to be real close up on this part. I'll zoom back out later, but as soon as I added more space to the page, it made everything really tiny. So what is our point estimate? 0.53 plus or minus Z star. Let's talk about this guy. So to get my Z star, we're doing a what percent? 99%. So I need to do inverse norm of what? 1 minus 0.99 divided by 2. Okay. So what is our Z star here then? .576. And then we do square root 0.53 times 0.47 over 150. So 0.53 plus or minus, what do we get from all this junk? 0.105. So my confidence interval would go from what to what? You said 0.425 to 0.635. So there's my interval. All right, we've got state, we've got plan, we've got do. The last part, conclude. My handwriting's about to get messier, sorry. All right, so how would we conclude this then? Yes, we are 99% confident that the interval from 0.425 to 0.635 captures the true proportion of visitors to Yellowstone who favor the proposal. I will make sure on the test that you have enough room to do all 4 of these steps. You do not get that 4-step process like layout form. You have to know how to do this start to finish with a blank space. But I've given you like 3/4 or more of the page to do this. You should have plenty of room. If for some reason you need extra paper because it doesn't fit on the amount of space I gave you, you can ask me for extra paper. We'll just staple it together. I think we'll be good because it's literally like everything but the question stem, the rest of the page you get. All right. All right, so that's part A. Question 15 has 2 more parts. So let's go look at part B. Yep, sorry. There's everything. 12 or 13. It's pretty much the same format as last semester. It's 10 multiple choice and then between 2 and 3 short answer. Obviously, if I'm going to ask you to do this twice, I'm probably not going to ask a 3rd question unless it's super quick, right? Because this whole thing takes a while to write out. I know yesterday for the FRQ, it took us a good 10, 15 minutes to do that. Part B, based on your work in Part A, is there convincing evidence that more than half of all visitors to Yellowstone National Park favor the proposal? What would more than half have to look like? Yeah, everything in my interval would have to be above 50%. Is everything in the interval above 50%? No. So I would say no. We do not have convincing evidence something really important here. Make sure you get context in here. We don't have convincing evidence of what? Sorry, that zoomed way, way in. We don't have convincing evidence of, yeah, that more than half of all visitors to Yellowstone National Park favor the proposal. Oh, good grief. Come on. Why? You could say it like that. To make it short and sweet here on the because, if the number that they're asking you about, is it more than this? Is it less than this? If that number is inside the interval, if it's completely contained in the interval, then you don't have convincing evidence of that. Our interval would have to contain only numbers bigger than 0.5 for us to have convincing evidence that it's more than half. Because the interval contains (0.5). The random sample was actually 168 visitors, but 18 people never responded. Does this change your answer to part B? Explain why or why not. All right, so let's remember the claim in part B, or we want to know, do we have evidence that more than half of the people feel this way? So what happens to my interval if these people had responded? It could go up or down. Let's assume, like, best case scenario, they all come back and they're like, yes, we are in support of this. How would that change your p hat? It would be higher. How much higher? Instead of 79 over 150, it would be 97 over 168, which is what? 0.577 or 0.58, right? That's not a huge change to our p hat, is it? It went up. To be fair, it went up, but it didn't go up a ton. So if I did 0.58 plus or minus 2.576 times the square root of 0.58 times 0.42 over 168. What would my new margin of error be now? What's the new margin of error now? .098. What was the old margin of error? 0.105. Why did the margin of error go down? We increased our sample size, margin of error goes down. We kept the same confidence level, that 2.576 didn't change. Okay, so my new margin of error is 0.098. So what's my new interval? .482 to 0.678. So would that change our answer to part B? Why not? Yes, 0.5 is still in the interval. No, it does not change my answer. Mm-hmm.
Like recorded?
Yes, the video for this will be up. The answer key is already up, which is written much more nicely and neatly than this, but it's all the same basic ideas. Yes. Where did the 97 come from? Oh, that? So my old p hat was 79 over 150. And that's how we got the 0.53. These 18 people that never responded, we're pretending like we know their answers. We're pretending like we know their answer is yes. The reason that we're pretending it's a yes instead of a no is I want to know if they all said yes, would that now be convincing? So my argument was that more than half felt this way. So if those other people were to come in and answer, would that tip the scales to now make it more than half? Does that make sense? If they said no, then it's definitely not more than half, because it already couldn't be guaranteed that it was more than half. But if they all said yes, maybe that tips those scales a little bit further, and now I would be like, yeah, my interval contains only numbers bigger than 0.5. So I made an assumption in the direction that they were talking about here. More than 0.5, so I'm adding. If I'd wanted to know, is there convincing evidence that it's less than half? Then I would have assumed that they all said no, and I would have 79 over 168. So you want to make your assumption in the direction that they're talking about here. Since it said more than, I added. If it said less than, then I would have just like not added. You wouldn't take it away. It doesn't change anybody else's answers. Does that make sense now? Okay. What else would you guys like to look at? Yes. Problem number 1, absolutely. Yep.
So, like, how this one, part A said construct and interpret the interval, on number 17, it just says calculate and interpret. So, like, do you have to do all of the steps?
Calculate and interpret is, for all practical purposes, this is the same thing as construct and interpret. You got to do all the stuff, yes. Because you cannot calculate a confidence interval without knowing that you're allowed to calculate the confidence interval. All right, question number 1. A random sample of 900 individuals has been selected from a large population. Why would that be important to include? Yeah, we're gonna be able to assume some independence here, right? Because what would my 10% condition be? We would have to have at least what to get independence? Have to have at least 9,000. So 9,000 is less than or equal to whatever my population is. I haven't finished reading the question. And because it says it's a large population, I'm comfortable with making that assumption. That's like 2 or 3 large high schools put together. It was found that 180 are regular users of vitamins. Thus, the proportion of regular users of vitamins in the population is estimated to be 0.20. The standard error of this estimate is approximately. Standard error. That's all that square root stuff. P hat times 1 minus p hat over n. 180 out of 900, it says that we are estimating that at this 0.20, so there's my p hat. So to find my standard error, I do 0.20 times 0.80 over what? Over 900. And from there, you can pop that all into your calculator. Standard error is margin of error without the z star. It's your standard deviation of your sample. Mm-hmm.
Can we do 3 and 4? Could you explain like why?
Mm-hmm. Yeah, numbers 3 and 4, absolutely. This one, by the way, when you pop it into your calculator, you should get something close to D. 0.0133. Something reasonably close to D. All right, number 3 and number 4. A polling organization announces that the proportion of American voters who favor congressional term limits is 0.64, or sorry, 64%, so 0.64 for our p hat. With a 95% confidence margin of error of 3%. So 0.64 plus or minus 0.03. If the poll were conducted again in the same way, there is a 95% chance that the fraction of voters favoring the term limits in the second poll would be between 61% and 67%. Where did they get these numbers from? The margin of error. They plussed and minused to that 0.64, right? Is there a 95% chance that this would happen again? Think about what a confidence level means. What does a confidence level mean? Do you guys remember the day when we took a whole bunch of confidence intervals? We used the applet, and we just did them one after the other, after the other, after the other, after the other. We did a bunch of samples. Yes. 95% of the time, my confidence interval is going to capture the true proportion. It doesn't mean that it'll fall in between 61% and 67%. That's not what my confidence level means there. Confidence level is saying if I use these same procedures over and over and over and over and over and over, 95% of the time, I'm going to capture that true proportion. My true proportion will be in that interval. 5% of the time, it's going to be a swing and a miss. My procedures didn't change. We just had some weird data to work with, and it didn't capture that true proportion. It does not mean that there's a 95% chance that the next time I do this, it's going to turn out the same. If there's a 95% probability. Nope, back up. That is not what 95% confident means. We are not talking probabilities. Nope. If the poll were conducted again the same way, there's a 95% probability that the percent of voters favoring the term limits in the second poll would be within 3%. Probability, no. This is not probabilities. Among 95% of the voters, between 61 and 67% favor term limits. I don't know what that true proportion is. So I don't know that that's correct. That's not what my confidence interval is telling me. I'm 95% confident that it's between those numbers. But it does not mean among 95% of voters. My confidence here is what is 95%. Not 100% positive, 90%, 95%. None of these are talking about if I did this many, many, many times. My procedure repeated the exact same way each time. 95% of the time, that process will capture the true proportion. Suppose the poll in the previous question was conducted by email, and those conducting the survey are concerned about the possibility of undercoverage since some people don't use email, or they have filters that block mass emails. Is this a valid concern?
Yeah.
Absolutely. If you're conducting a poll by email, expect a very low response rate, right? Is this a good way to collect a sample? If you don't have a good sample, are you going to get good data from that?
No.
How do you fix that problem? Do it again with a better method of collecting that sample. So throw it out and start over again with a better sampling method. If you have a bad sample, you're going to have bad data, and you can't fix bad data. Throw it out and start over. So don't use email to collect a sample. Yes? Number 5? Absolutely. Did you have another question, Maya?
No, well, I was thinking, like, I just said D, because I thought, well, if you go larger, you get a better chance of getting.
Well, if I have a larger sample, I'm still going to run into the same problems with the way I got my data. I mean, think about the people that are likely to respond to emails. Are they representative of the whole population you're interested in? Probably not.
Okay, that makes sense.
Yeah, so if it's not a representative sample, making it bigger doesn't fix the problem. Yes? How is it not part A?
Yeah.
Okay, so here, for this particular sample, our confidence interval is between 61% and 67%. So we're 95% confident that the true proportion is in there somewhere. Are we guaranteed that the true proportion is in there? No. If I do the sample again, new people, same method, and I calculate a confidence interval again, is it possible that that one could be wildly different than this? It is. If this one did capture the true proportion and my next one is one of those 5% that doesn't, they could be wildly different. Or maybe this is the one that's off and the other one is actually capturing the true proportion. Does that make a little bit more sense? This method is not guaranteed because we're working with samples and we're doing our best to get a good sample. There's always sampling variability. Maybe people are going to lie to me when I ask them this question. I can't control for that. I can try, but I can't control for that if they're not telling the truth, or if I try a random sample, but there ends up being a pattern in the, like I end up pulling all guys and no women in this random sample. That wouldn't be representative of my population, right?
The only reason I was thinking that is because it says like 95% chance. It's not saying it's going to be in between those.
So again, this idea on that a confidence level is talking about a probability or a chance. That's not what 95% confident means. 95% confident means if I do the same thing again and again and again and again and again, 95% of the time, it's going to give me back valid data. It's going to give me back a valid interval. 5% of the time, even though I did everything right, it's not going to give me an interval that actually captures the true proportion. Does that help a little bit? On questions like this, if they're asking you what 95% confident means and you see the word probability or chance show up, absolutely not. That is not what a confidence level is conveying. No chance stuff. So when I read through this, when I was working on this, anytime I saw chance or probability, I immediately threw it out. 95% confident does not mean there's a chance of. All right, number 5. Oh, and then we're almost done. Oh my goodness. Some scientists believe that a new drug would benefit about half of all people with a certain blood disorder. To estimate the proportion of patients who would benefit from taking this drug, the scientists will administer it to a random sample of patients who have the blood disorder. What sample size is needed so that the 95% confidence interval will have a margin of error of no more than 3%? How do we calculate margin of error? Z star square root of p hat times 1 minus p hat over n. I know I want the margin of error to be no more than 0.03. And I want it for a 95% confidence interval. What's my Z star for 95%? 1.96. And what p hat are we working with? 0.5, because we don't know. So 0.5, yep. Because that's my margin of error. Interval will have a margin of error of no more than 3%. This right here is that. Yes. And then over n, because we don't know n. So we're going to divide both sides by 1.96. And then we're going to square both sides. So that would be equal to 0.25 over n. and then flip places between the n and the thing on the other side of the equal sign, because you would multiply both sides by n and then divide by those parentheses. When you do that, remember, we always round which way if it comes out to be a decimal? Always round up. You should get something around here when you round up. When I did my division and squaring and all that jazz, I got 1067.111. I will happily take questions over the weekend if you hit me up through Canvas. Any question is a good question, as long as it's somewhat on topic. I can't answer questions about science or English. I can only answer questions about math. But please feel free to get a hold of me if you guys have any questions about anything.